This is section 4.7, Graphing Linear Equations. We've already talked about lines in slope-intercept form. Slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. This is also called function form because y is isolated on one side. So we're looking at y as a function of x. But more specifically, you can write function form like this. F of x equals mx plus b. You'll note that this is read as the value of the function at x or f of x. Most times I will call it f of x. It is not a multiplication of f of x, but saying that the value of the function when x is a certain value is what is on the other side of the equal sign. In other words, f of x is y. The value of the function for a certain value of x is y. They also use other letters to represent this function form. You might see g of x or h of x, but they all mean the same thing. The value of the function when x is a certain numerical value is whatever. You can calculate the value of the function by substituting the x value into the function and calculating y. Please note here that we're not manipulating the equation and moving things from side to side. Everything that's on the right side will stay there, and the value of the function will remain on the left-hand side. So if we ask to find the value of the function f of x equals 3x minus 15 when x equals negative 3, you would write it like this. F of negative 3 equals 3 times negative 3 minus 15. The value of the function at negative 3 is 3 times negative 3 minus 15. When you simplify, you get negative 9 minus 15. And finally, when you add those together, you get negative 24. So f of negative 3 is negative 24. Let's try another one. Find the value of f of 2 that equals negative 2x plus 8. So we're going to substitute 2 into the function to calculate the value. F of 2 equals negative 2 times 2 plus 8. That's negative 4 plus 8. That's 4. You can also start with the function value and find x. So if they say that f of x equals 2x minus 10 and f of x equals 6, to find x, you would set the function equal to 6 and solve for x. Remember, f of x is the same as y. So if they're telling you f of x equals 6, that means y equals 6. So here in the next step, I've substituted 6 in for f of x to get 6 equals 2x minus 10, 16 equals 2x, and x equals 8. If, when x equals 8, f of x equals 6, then it can be written like this. F of 8 equals 6. The value of the function when x equals 8 is 6. That's how that is read. If f of x is the equivalent of y, then it should be really simple to graph. You'll be looking at points like this, 6 and f of 6. Given a function, you have to substitute the x value to solve for y. So for example, it says graph the following points for the function f of x equals 4x minus 1. I want f of 0, f of 2, and f of 4. That means the x values are 0, 2, and 4. Now we have to calculate the y values for the function. So f of 0 equals 4 times 0 minus 1 equals negative 1. F of 2 equals 4 times 2 minus 1, that's 7. F of 4 equals 4 times 4 minus 1, that's 15. That means your 3 points are 0, negative 1, 2, 7, and 4, 15. I've taken the f of values and substituted them for y in order to plot the points. You'll see that on the next page. Here's the graph. The points are 0, negative 1, 2, 7, and 4, 15. I plotted the points in red. And I would connect them to draw a line, but I wanted to be clear where those points are for you and did not want to cover them up. Given those 3 points, you could determine the slope and the y-intercept and write the equation for the line. If I just gave you those 3 points, I'm sure you could write the equation for the line had we not seen it on the first page. All you would have to do is take the change in y over the change in x to determine the slope. That's 8/2 or 4. And use the y-intercept that's actually given in the first point. You see the first point is 0, -1. When x is 0, then the y value must be the y-intercept. So our y-intercept here is -1. We could draw this easily by starting at -1 and using the slope of 4. Or you can plot the points as I've done here. It all represents this function, f of x equals 4x minus 1. The domain and range. We've talked about both these terms before. The domain are all the values of x for which the function is defined, and the range is all the values of fx in the range. The y values are based on all the possible x values. So to graph and determine the domain and range, we're going to take a look at a word problem here about the number of gray wolves. They tell you that the number of gray wolves can be modeled by this function, f of x equals 37x plus 7. Here, x is the number of years since 1995. They want you to graph the function and determine the domain and range. Here I made an input-output table. I looked at f of 0, f of 1, and f of 2. In other words, my x values were 0, 1, and 2. When I substituted them in, I got 4 y values, 7, 44, and 81. Here you know from the outset the domain must be greater than or equal to 0 because the domain is time since 1995. We're not going to go back in time. We need to go forward. Now at 0, we would find the number of wolves in 1995. We could do that, or we could go forward. So x must be greater than or equal to 0. We're beginning here at the beginning year and going forward. So this has no negative numbers in the domain. The graph of this function begins at 7, that's the y-intercept, and it has a slope of 37. I plotted the 3 points and constructed the line, the 3 points that I had calculated on the slide before. From this, you can see that the range, the y values, are y is greater than or equal to 7. Always use the lowest possible value in the domain to get your starting point for your range. Because x can only go as low as 0, then that means that y must begin at 7. So take the lowest number in your domain, substitute it into your function, calculate the y, and that is the beginning of your range. That's really important. We're going to look at families of functions here. A family of functions is a group of functions that all have similar characteristics. For example, the functions with the form f of x equals mx plus b, that's the family of linear functions. But in these linear functions, there's actually a parent function, a basis for all the functions, and the most basic linear function is f of x equals y. That means y equals x. So no matter what x is, y is exactly the same value. You'll see there's no slope except 1, right? It's not greater than or less than, so there's nothing tricky here. And the y-intercept is 0. This line, when you plot it, is the blue line to the right. The line is upward sloping, and it's going to run at a 45-degree angle through the axis. It does that because when x is 1, y is 1. When x is 2, y is 2, and so on and so forth. You can add to the family of the functions by changing one aspect of the function. So if you change the slope, you'll shift the angle of the line. So first we're going to draw the parent function again. The parent function in this case is blue, okay? And you'll see that f of x equals x. That's straight through at the 45-degree angle as we did before. That blue line is the parent. But now I'm going to start to shift the lines around. I'm going to look at other members of the family. Let's change the slope. You know, in the parent, the slope is 1. But what if I change the slope to 2? Okay? Look at the red line for f of x equals 2x. The greater the slope, the sharper the line. So what it does is it shifts the line to the left. It makes it more upward or sharper when you draw it. Now, if we made the slope negative, okay, the line would run from upper left to lower right. Look at the green line. That's the change in the parent function when you change the slope. If it's greater, positive, it's going to be sharper. If it's negative, it goes the opposite direction. What if it's between 0 and 1? Then that's going to make a flatter line that actually goes underneath the blue line. So let's draw some conclusions here, and these you should really understand. If we're looking at a family of linear equations, tweaking the equation will actually change the line. Okay, so first case, if you increase the slope, if m is greater than 1, that's going to raise the line. It will be sharper than the parent, but it will follow the same direction. Decreasing the slope so that it's still positive, but it's between 0 and 1 will lower the line. It will follow the same direction, but it will be flatter. Decreasing the slope even more so that it's less than 0, so that you have a negative slope, will actually reverse the direction of the line. If you add a y-intercept, but keep the same slope, it will raise the line if the y-intercept is positive and lower the line if it's negative, but it will run parallel to the parent line. It will not change slope at all. Okay, so it's going to run parallel exactly with the parent, but it's just going to be either above it or below it. You should be able to compare the graph of any linear equation with that of the parent. And let us know what's happening here. Is slope increasing or decreasing? Is the y-intercept increasing or decreasing? So that you can see the change that those numbers do, how they affect the parent.